Okay, so let's take 1 over x minus 1 plus 3 over x plus 2 equals 11 over x squared plus x minus 2. All right, before we get started, let's make sure all of our denominators are completely factored, which means I can factor this one. Two numbers that multiply to a -2 but add to a +1. Okay, so now I'm going to multiply both sides by my least common denominator. So that means I want to pick an expression that all of my denominators will divide into evenly. So we'll take x plus 2 and x minus 1. And it might be helpful to think of everything as a fraction. So now we'll start to distribute this to these two terms, and then we'll do this multiplication. Okay, so we have x plus 2 times x minus 1, times 1 over x minus 1, plus, we'll do it again, x plus 2 times x minus 1 over 1 times 3 over x plus 2 equals 11 over x plus 2 times x minus 1 times x plus 2 times x minus 1. All right, let's see what we can cancel here. I can cancel a factor of x minus 1, and I'm left with x plus 2. We're adding. I can cancel a factor of x plus 2, which leaves me with 3 times x minus 1. And then both will cancel here on the left, and that leaves me with 11. So let's clear these parentheses and see what I have. So that's what 3x minus 3 equals 11. Collecting like terms, this gives me 4x minus 1 equals 11. So this is linear. Let's get x by itself. Taking the 1 to the other side, I have 4x equals 12. Dividing both sides by 4, I get x equals 3. These need to get checked too, but I'm primarily checking to see that I'm not going to divide by 0 when I sub in my solution. So what two values of x can't x be? So x can't be 1 and x can't be -2, right? Because if it were, I would divide by 0 when I substitute in. I didn't get 1 or -2, so my solution of x equals 3 is correct.